Okay, today we are learning about 1.3 exponents. Let's go through all the rules of exponents. x5 times x to the fourth, bases are the same, you add your exponents. What happens when you have a power raised to a power? Is it going to be 7 or is it going to be 10? You multiply them together. It makes 10. What happens when you divide exponents? You take away the smallest one, and if you took away 3 x's on the top, you also have to take away 3 x's on the bottom, which ends up being 1 over x squared. How do you do negative exponents? Negative exponents do not give you negative answers, they give you fractions. It's 1 over 4. Anything raised to the 0 power is 1. Everything inside of here has to be raised to the second power. 3 to the second is not 6. It's 3 times 3, which is 9. A to the fourth, B to the sixth. This one, again, negative exponents. Basically, when you do a negative exponent, everything in the numerator goes down into the denominator, and everything in the denominator comes up into the numerator. And once you flip them, you can change it to a positive 2. So your final answer is everything inside of there needs to be raised to the second. You're going to get 9 over 4x squared. So those are the rules for exponents. Let's go over an exponential function. This is an exponential function. Y is equal to ab to the x. I'm just going to give you y equals 2, 3 to the x. Y is equal to 2, 1/2 to the x. Y is equal to 4 to the negative x. And y is equal to a negative 4, negative x. I'll give you a couple of minutes to write those down. Okay, let's graph the first one. This 2 is where you put your first dot on the y-axis. This 3 lets you know if it's increasing or decreasing. And since it's greater than 1, 3 is greater than 1, your graph increases. And I think by now, if you're in calculus, you should know what an exponential graph looks like. This one, again, I put my first dot at 2. This number is less than 1, so it's going to decrease. Don't hit the, there's a horizontal asymptote at y is equal to 0. It gets closer and closer to it, but it doesn't touch it. Okay, how do you do these? Well, you're supposed to have a 1. You're supposed to have a 4 to the negative 1, and then that's supposed to be a positive x. Remember, if the formula up above has a positive x, so I'm going to make that 4 to the negative 1, and remember that 4 to the negative 1 is really a fraction, which is 1/4 to the x. You need the a. You need the b. The a is where you put your first dot at. It's at 1, and you know that it's a decreasing graph. I have a feeling in calculus they're going to write it more like this than the ones up above. The same thing with this one. Y is equal to, I'm going to ignore the negative sign. It's going to look like 4 to the negative x, so I'm just going to make the same thing that I did over there. I'm going to ignore the negative sign. Do you know what the negative sign does to the graph? The negative sign flips it, so it would look like this. I would probably graph the original and worry about the negative sign afterwards and flip it. So again, this chapter is all review. I should go a little bit faster in this chapter because this is all, you had this in Algebra 2, you had this in college algebra, this is nothing new to you. Okay, rewrite using base numbers. 25 to the 2x, and they want you to use the base number 5. You want to change 25 to 5 to the second, and that's still raised to the 2x power. And remember what your law is? You multiply these two together, and the same thing, 25 to the 2x is the same thing as 5 to the 4x. They want you to write it in base 2. I know that 1/16 is the same thing as 1 over 2 to the negative 4, 2 to the positive 4, raised to the 3x. 2 times 2 times 2 times 2 is 16. I don't like it up in the denominator. I'm going to bring it back up, so if I flip it, it becomes 2 to the negative 4 raised to the 3x, which ends up being 2 to the negative 12x. Okay, how to solve this problem using a calculator. So get your calculator out again. You're going to use your calculator a lot. Using your graphing calculator, and you're going to use the intersection button. You're going to find out where these two intersect with each other. But before we do 2 to the x equals 5, I want to do a basic one just to show you. I want to do y equals 1/3 of an x plus 5. And I'm hoping you know that makes a line. Y is equal to 1/3 of an x plus 5. And y is equal to 3x plus 13, which is also a line. So let's do this. So under your calculator, so look at your calculator. Hit clear so that you only have a blinking little box. Do you notice that you have gray little buttons on the top of your calculator, or maybe a different color? But the first one says y equals, the second one says window, the next one says zoom. These are all used for graphing. Those buttons up on top are used for graphing. So what I want you to do is hit the y equals button. And under the y equals button, you have a y1, a y2, a y3, a y4, a y5. You can scroll down. That means you can put that many equations into your calculator. I'm going to let y1 equal this, and I'm going to let y2 equal that. So I'm just going to plug in 1 divided by 3. So hit 1, hit your division sign, divided by 3. 1 divided by 3. Your x or your variable button is next to your alpha button. Do you see your green button called the alpha? Next to that is there's an x, a t, a theta, and an n, and we're going to use the letter x, and then you're going to put plus 5 in there. And then you're going to put in 3x plus 13 under y2. Then what you're going to do, once you put 1/3 x plus 5 in there and 3x plus 13 in there, let me just get this in there quick. I am a little bit slower than you, I guess. You also, to put 1/3, you could use alpha F1. If you look above the little y equals button, you'll see the F1 button. If you do alpha F1, the first thing that shows up is the division thing, and you're going to use that a lot. So alpha F1, that's what I just did. I used my division button to do 1/3 x plus 5. Now, way over here, under those tabs is the graph. So hit your graph, and you'll see these two cross each other. We hope. Yep. It looks something like this on your calculator. They cross over here in the second quadrant. I know this is, let me do it again, sorry. They cross in the second quadrant, so it looks like this. They cross right here, and you want to know where they cross. So, do you see this button over here? I want you to hit second, calculate. So you have to hit second, calculate. And you see that the word intersect is number 5 down there, so hit intersect. And now you have a blinking light, like I have my blinking light right here. I'm going to move that blinking light where I think they're going to intersect. So I'm going to move my little cursor to where I think it's going to intersect. And then once I have it where it's intersecting, I just hit the enter button. Then I hit the enter button. It's guessing where it is. And now I hit the enter button one last time. At the bottom of your screen, it should say the intersection is at -3, 4. It does the work for you, your calculator. The intersection button is a -3, 4. So these were two lines. Now we're going to do the same thing with this one. So I'm going to go back to my y equals, and I'm going to go clear my two equations. I'll wait for you guys to go back under y equals, and I want you to clear your y1 and your y2. My y1 is going to be this one, and my y2 is going to be this one. So under y1, I'm going to do 2 raised to the x power, and under the y2 is going to just be a 5. If you know anything about this, you know that this makes an exponential equation like this. And if you know anything about y2 equals 5, this is going to make a horizontal line like this. And where they intersect with each other is where we're going to find. So hit your graph, and they should do what I said they're doing. They're going to make an exponential function, and it's going to make a line. And where they intersect, how do you get to intersect? You go second calculate and hit the intersection button. Move my cursor to where I think it intersects. I'm going to move my cursor to here, and I'm just going to keep hitting the enter button. And it says it intersects exactly at 2.322, 5. In calculus, you have to go out to 3 decimal places. Remember that for the rest of the year. You will be docked if you don't go out to 3 decimal places. So from now on, you go to 3 decimal places. Okay, part 3. Part 3 is what is the change in y. So here is your x values, here's your y values. I talked about in 1.1 what that little triangle stood for. It stood for delta. Delta means what's the change in y? Well, what's the change between 1 and 4? 3. What's the change between 4 and 9? 5. That's all you're doing in that section. Okay, I think we're on the last page already. How long to double your money if it's compounded annually at 2.32%? How long will it take you to double your money if it's compounded annually at 2.32%? Again, we're using y is equal to ab to the x. That's the percentage. We're trying to figure out x, the amount of how long it's going to take to double your money. What's your initial money, and what do you want to find at the end? Well, you want it to double. It doesn't matter what you use. You could do a 1 and a 2. It's the double. You could do a 5 and a 10 if you want to use. You can use 100 to 200. You just want to double your money. It doesn't matter which numbers you use. I'm just going to do the most basic number. I'm going to do 1 and 2. If you wanted to, how long it's going to double, I got to change this to 0.0232. I got to change that to a percent. And I want it to go up. If I want it to go up, I add 1 to that. If I want it to go down or depreciate, I subtract 1 from 1 minus 0.232. If I want my money to go up, I add it. If I wanted to depreciate, this would go down. So now all you're going to do is use your calculator. I don't need that there. So under y1, I'm going to put 2. Under y2, I'm going to put 1.0232. Let's do that again, just like you learned on the last page. So go back under y equals, clear them. I'm going to wait for you to clear them. Under y1, I'm going to put the number 2. Under y2, I'm going to put in 1.0232 raised to the x, and I'm going to hit graph. Okay, I'm glad we did this one. Do you notice that your graph, not like the last one, it looked like this. This one, it doesn't look like they're even intersecting with each other. those 5 buttons up there, you have to get used to zooming in and zooming out. I'm gonna change my window. The most standard window goes from a -10 to a +10 on the x-axis, from a -10 to a +10 on the y-axis. I want you to change your window. It says window, and everybody hit the window, and you can see that the x-axis counts a -10 to a +10, and x scale means it counts by ones. I'm gonna change mine. I'm just gonna play around with it. I'm gonna start my x minimum at a -5. I'm gonna change my x minimum to a -5, and I'm gonna change my x maximum, my domain, to a +100, just to play around with this. I'm gonna change my y minimum. I'm gonna change my y minimum to a -5 and my y maximum to a +5. And now I'm gonna hit graph. And when you hit graph, do you see that now you can see where it intersects with each other? So you can change your window anytime you want so that it'll fit the graph. That's a very important button on your calculator. Do you remember how to go into intersection now? Now you go under second calculate, second trace, you guys. Hit second calculate, find the intersection, which is down to number 5. Move your cursor to where you think it's going to intersect, and keep hitting the enter button until it says intersection on the bottom. It's going to intersect, you guys, at 30.222 when y equals 2. It's going to take 30.22 years for it to double its money. Okay, one more. The population of Rush Lake is 32,000 people. That's the beginning, 32,000 people. It's going to increase at a rate of 2.25, so 1.0225 to the x. How long will it get to 75,000 people? How long will it take to get to 75,000 people? You can only have this left on the right-hand side. I have to divide both sides by 32,000 first, which gives me 2.34375 on the left-hand side equals 1.0225x. I want to know how long it's going to take for the population of Rush Lake to go from 32,000 to 75,000. This is my y1, this is my y2. So go to your y button, clear it, and put in under y1 2.34375, and under y2 put in 1.0225 raised to the x, hit your graph. If you don't like your graph, you can always change your window. The windows are your x values and your y values. If you don't want to use your window, you can play around with your zoom button. You can zoom in and you can zoom out, so you can play around with the zoom buttons. Let's just hit the zoom button. And you just see under number 2 it says zoom in, number 3 it says zoom out. 6 is really important. It's called Z standard. It's called the zoom. We'll go back to the standard form, and the standard form is a -10 to a +10, a -10 to a +10. If you arrow all the way down, there's called a zoom fit. It'll try to fit it to your graph. But whichever one you want to use. But how do you get your intersection button? Do second calculate, hit intersect, and move your cursor to where you think it's going to intersect. How long will it take Rush Lake to more than double in population? It'll take about 38.280 years to increase. So, one last thing, radioactive is also in here. I just want to talk about radioactive, and then I'll let you start doing your assignment. Radioactive deals with fossils. It also deals with science. This is where science and math kind of go hand in hand with each other. There's a formula for radioactive decay, RD, radioactive decay. It's the initial amount, it's the half-life raised to X divided by time. So for example, a fossil, you want to know how long it's going to figure out the radio decay of a fossil, and let's say it'll take 15 days for the radioactive to begin, and you want to know how long it's going to start. The initial was 2.4, and you want to know when it's going to go down to 1. 2.4 down to 1, and you're going to put a half, because the half is part of the formula, X divided by 15. The first thing you're going to do is divide both sides by 2.4. This is going to be Y1. This is going to be Y2. Hit your intersection button and it'll tell you how long it's going to take for that fossil to go from 2.4 down to 1. So there's just an example of a radioactive. So that is it for 1.3. Basically, it's all about exponents.